Hey guys, so I had some questions about Lab 1 and I wanted to kind of give you a little bit of a background which I think will help you guys understand what's exactly happening in this lab. So there are 4 different levels of your protein structure. The first is going to be your individual peptides. So I'm going to kind of try to draw these out. If you think of a peptide, each one of these being an individual amino acid, this would be your primary level. Your secondary level is going to be things like alpha helixes, where you have some sort of hydrogen bonding networks. Your tertiary level is going to be the complete collection of all of the alpha helixes together. And I don't know if I'm going to be able to draw this, but it basically just looks like a giant blob, and you can imagine there's a bunch of different alpha helixes in there. And your quaternary level is going to be where things are no longer being held together covalently. So everything in the primary, secondary, and tertiary, these structures are held together by this peptide backbone, which is a covalent bond. If your quaternary structure, and I'm just going to indicate proteins as circles, you might have 4 of the same protein, and they're just being held together by hydrophobics. So say you have this section here is really hydrophobic, so 2 of them are going to clump together, and if you have another one up here, you might get 4 of them that clump together like this. So for doing these gels, when you have something like this, and you don't treat it at all, it's going to show up on your gel the same way it would before, as this big conglomeration that's going to be, if we give each of these a weight of 25, this would have a total weight of 100, and on your gel you're also going to have a total weight of 100. And if you think about it, you have like millions of these in solution, so it's not just like one of these going to one of these. You have your gel bands are an accumulation of a vast number of proteins that all weigh the same. Once you heat it though, or add SDS or do some sort of denaturing, this is going to fall apart into 4 of these. So now the weight of your structure is only going to be 25, what you see on the band, versus over here where you didn't do some sort of denaturing, you'll end up with a band at 100. For the different types of disulfides, these can be attached together. So even if you denature here, this is a covalent bond. So if you don't do something to reduce that, it's not going to make a difference. Now this is an intermolecular disulfide because it's in between 2 different tertiary structures. Now if you add in if you add in some DTT, this is going to reduce your thiol and give you 2 separate SHs. So again, if this is a weight of 25, the total structure weight is going to be 50 here. It's still together, so you're going to have another 50 here versus over here, 25, 25. This will give you a band only at 25. You have the intramolecular disulfide. So let's say both of these have an intramolecular one. When you denature, it'll separate them. There's no longer a covalent bond between these 2. So you're going to end up with 2 equivalence of this regardless of whether or not sorry, give me a second to draw this out. You were to add in DTT. In this case, it's technically going to be 2 atoms bigger because you have these 2 hydrogens here, but you're talking about such a small number in comparison to an entire protein, which is thousands of kilodaltons, so this would be 2 kilodaltons bigger than this one here, which is negligible in a gel. So this has a weight of 50K. This is 25. This is 50. And this is still 25. So that's how you tell if it's an intramolecular disulfide, because the DTT won't make a difference. Hope this was helpful. If you guys have other questions, please send me an email.